All right, welcome to The Explainer, where we try to make complex stuff simple. Today, we're going to dig into the world of data mining. You know, that powerful process that takes these huge oceans of raw data and somehow turns them into real, actual insights you can use.
So, let's just start with a reality check. Something we all kind of know, right? We are absolutely drowning in data. I mean, every single click, every purchase, every single interaction, it all creates this digital footprint. And the amount of information being stored right now, it's just staggering.
So, a simple search? That's just not going to cut it anymore. The real challenge isn't just storing all this data, it's about making sense of it. So how in the world do we dig deeper and find all those valuable patterns, those predictions that are just buried deep inside all that noise?
And that question right there, that's really at the heart of this huge shift. We've moved from just collecting data to actually needing to understand it. And that's created a whole new set of demands, right? Businesses especially, they need to know what all this information really means for them.
Yeah, exactly. It's not about simple lists anymore. The game has changed. Now it's about getting sophisticated insights. You know, businesses don't just want to know who their customers are. They're desperate to know what those customers are going to do next.
And this is where data mining steps in. Think of it like a high-tech detective for your data. It goes way beyond just a simple search to uncover patterns and relationships that you just never see at first glance. Some people call it exploratory data analysis or data-driven discovery, but it's all the same idea.
Okay, so let's really get into this. What is the difference between data mining and just, a regular database search? It's a really common question, and honestly, the distinction is super important.
In this chart, it lays it out perfectly. A traditional query, that's like walking into a library and asking for a very specific book. You know exactly what you want, you ask a precise question, and you get a precise answer. But data mining, that's more like going up to the librarian and saying, hey, just show me something interesting about customer behavior. You start with this kind of vague goal, and the whole point is to uncover patterns you didn't even know existed.
So here's the absolute key takeaway. Data mining isn't just about finding data. It's about creating a model, basically a framework for understanding that data. The algorithm chews through all the information and figures out a model that best explains what's going on. And it turns out pretty much all of these data mining models fall into one of two main buckets. And if you can get your head around this split, you're well on your way to understanding the whole field.
Right, so this flowchart is basically our roadmap. All data mining models are either predictive, which means they use past data to try and forecast the future, or they're descriptive, which is all about finding interesting, hidden patterns in the data we already have. So one looks forward, the other looks inward. Simple as that. Okay, so let's go down that predictive path first. This is all about looking at what's already happened to make really educated guesses about what's going to happen.
So a really common predictive task is something called classification. Basically, this is where we take new data and sort it into categories we've already defined. It's called supervised learning because we, the humans, supervise the process by telling the algorithm what the different groups are ahead of time.
Just think about your credit card for a second. Every single time you swipe that thing, a classification model is kicking into gear. It instantly analyzes the transaction, compares it to historical data, and boom, it slaps it into a predefined class. Authorize, ask for ID, do not authorize, and so on. It happens in a split second.
All right, another really powerful predictive tool is time series analysis. Now this one is perfect for tracking pretty much anything that changes over time. We're talking sales figures, website traffic, or, yeah, you guessed it, the most famous example, stock prices.
And this chart is a perfect example of that. An investor could look at this time series data to see what's going on with volatility and growth. You can clearly see that stocks Y and Z are kind of all over the place, doing similar things, while stock X, well, it's way less volatile and seems to be on a steadier growth path. That's the kind of insight that helps an investor make a much more informed decision. Okay, so let's back up and explore the other side of our roadmap, the descriptive models. Remember, this isn't about predicting the future. This is all about uncovering the hidden structure in the data we've already got. And the first big one here is clustering. This is where the algorithm automatically groups similar things together without us telling it what the group should be. And since the algorithm is figuring out the groups all by itself, we call this unsupervised learning. Pretty cool, right? And this is the secret sauce behind so much tailored marketing. A big retailer might cluster its customer base by things like income, age, and where they live. And that helps them figure out, okay,
Who gets the fancy high-end fashion catalog, and who gets the flyer for home goods? The clusters just reveal these natural segments that already exist in their market.
Another super powerful descriptive task is finding what we call association rules. This is the technique behind market basket analysis, which is just a fancy way of saying retailers look for connections between the different things people buy at the same time.
So, like in the example here, if a grocery store sees that when people buy bread, a whole bunch of them also buy pretzels, or that 70% of the time they also grab jelly, well, they might put those items near each other to boost sales. But the classic, maybe legendary example you always hear about, it's the story of a supermarket that discovered that men who bought diapers on Friday nights also tended to buy beer. Now, whether that's true or not, it perfectly captures the power of this stuff, finding these surprising, totally counterintuitive connections.
But, and this is so important to remember, this is just a statistical pattern. It's an association, not causation. There's no magical force that makes people who buy bread also buy pretzels. It's just a pattern that showed up in the data. And hey, that pattern could totally change tomorrow.
Okay, so we've looked at the different models. We've seen the kinds of tasks they can do. But where does data mining actually fit into the bigger picture? You know, the whole process of getting from a mountain of raw data to some actual knowledge?
Well, it turns out data mining is really just one step. A super important one for sure, but it's part of a bigger process called knowledge discovery in databases, or KDD. The best way to think about it is like cooking a meal. Before you can actually cook, apply the heat, which is our data mining algorithm, you have to do all the prep work first. You got to select the right ingredients, which is the data you need. Then you have to clean it, chop it up, transform it, and that prep work is everything. Because you know the saying, garbage in, garbage out. If you feed a brilliant algorithm messy garbage data, you're just going to get garbage results.
In this whole KDD process, it's happening literally all around us, all the time. It's shaping our digital lives every single day. It's why Netflix suggests that next movie for you. It's why Amazon recommends that product. It's behind the ads you see online. Which kind of leaves us with one final thought to chew on. Now that you know what to look for, where else do you see data mining at work?